So it was number 6 on the grade review,
Okay.
and number 11 too. But number 6, it's got a it looks like a 45-inch geometry.
Let me find, I got one here somewhere. Let me find one.
Yeah. See?
Okay. So number 6. Yes. Multiple triangle. So we've got this one, and that's a 30. We're going to try to find that. That's a right angle. You've got another right angle there. This is 3 square root of 5. Then we got a big 45, 45, 90 here. And this is 15 square root of 2. So in 45, 45, 90, we're going to start down here and we'll kind of work our way around this way. In a 45, 45, 90, the side lengths go x, x, and this is going to be x squared root of 2. So we can solve for the x here. If we divide by the square root of 2, we'll get x is 15. So then that's going to give us this side as 15. And so then we'll move to this triangle. And we don't have any markings other than it's a right triangle. So all we can really use here is Pythagorean Theorem. So I don't know this side. I'm going to call this side just a, from like a squared plus b squared equals c squared. So a squared plus the 3 square root of 5 squared is going to be the 15 squared. Is that okay? So we've got a squared plus, so the 3 times 3 is 9, the square root of 5 times square root of 5 is 5, and the 9 times 5 makes that a 45. And 15 squared is 225. So we'll subtract the 45 to the other side, and let's see, 25 of that will be gone, I think it'd be 180. So the a is going to be the square root of 180. So if you want, we can break this down. So let's see, I know it's going to be a 9 times 20. So that would be 3 square root of 20. 20 is going to be 4 times 5. Square root of 4 is 2 times 3 is going to make that 6 square root of 5. So now we know this side length is going to be 6 square root of 5. So then we move to the 30, 60, 90. And in the 30, 60, 90, now this is x, but that's not going to be the x that we're going to use in terms of how we name those side lengths. Let me just rename that n so it doesn't confuse us. In the 30, 60, 90, the short leg is going to be x. This will actually be 2x, and this long leg is going to be x square root of 3. So that means the x square root of 3 is equal to the 6 square root of 5. You okay to there? So then we'll solve for the x, so we're going to divide by the square root of 3. So we'll get now the 6 square root of 5 over square root of 3. We're going to have to rationalize here. So we don't want that square root of 3 in the denominator. So we'll multiply top and bottom by square root of 3. So these, because they're both in the radical, we can multiply their insides. So that'll become a square root of 15 on top. And on the bottom, we'll get rid of our radical, and that'll just be a 3. And then the 6 that's outside the radical and the 3 that isn't in a radical can cancel. in our scheme is 2 squared of 15. What we're looking for here is a 2x. So then we're going to multiply this by 2, and so we'll get 4 square root of 15. It's a long and winding problem. I love those. Good question. Anything else?
Can we do number 7?
7. So let's see what 7 has in store for us. So find the measure of the missing angle and write our answer as a decimal to the nearest tenth. So here we have a right triangle. Here's our angle that we're looking for. This is 13 and this is 6. So here we want to look for the trig function that's going to connect this side and this side. So for this angle, and if that's our right angle, this side is opposite, and that's the hypotenuse. So the trig function from SOHCAHTOA that connects opposite with hypotenuse is a sine. And that's going to be 6/13. So to solve for the x, we're going to do what we call the inverse sine of 6/13. Okay, and this didn't work for you?
No, I just wasn't sure because like we hadn't really gone over inverse sine, so I wasn't sure.
Yeah.
Okay.
Well, let's just do it real quick. I'm going to turn my huge calculator on here, and you can turn yours on as well. I'm going to make sure that we're in degree mode. This is good because we'll just for practice, we'll put this into degrees, minutes, seconds as well. It didn't ask for it in this problem, so we'll just give our answer in what's called decimal degrees. But then we'll also give it as an alternative answer in degrees, minutes, seconds. So you can go to mode and make sure you're in degree mode. And I'll share this with you momentarily. So mine is in degree mode. And so then I'm going to go seconds mode to quit and go back to what's called the home screen. So for this problem, we would just go second sine. There's our inverse sine, and then 6 divided by 13. And then to the nearest tenth, we would say that's going to be 27.5 degrees. We got a whole bunch more than that. So the answer to the question on this one was 27.5 degrees. We okay with that? Then let's alternatively give our answer in degrees, minutes, seconds. So just to remember, review, we're going to go, leaving the number that's on the screen, we're going to go seconds, apps button, which is our angle menu, and that option number 4 is the DMS. So it's going to take our answer and convert it when we hit enter. It'll convert it to degrees, minutes, seconds. And so we would then write that down, 27 degrees, 29 minutes, and 11.135 seconds. So that's a skill we need to have as well. Good questions. Anything else? Okay, so like I said, we're going to work on that worksheet for a moment. I'm going to come around and check some homeworks. You can work on that quiz worksheet and discuss among us. It's not going to be an actual quiz. We're just going to do that as practice problems, and we'll talk about those shortly. So you can discuss those while I'm coming around and checking homework. I'm going to pause the video for a moment. So I want to do a couple of these. So you need your calculator here, but can we find the coordinates of the point on a circle with radius? And I'm going to give you 2 different versions of this. So I'm going to give you a radius and an angle. So on the first one, we'll say the radius is going to be let's say 4.3, and the angle theta, let's say, is 7 pi over 8. And the second time we do this, we're going to say the radius is going to be 6.2, and the angle theta, we're going to say, is 312 degrees. So the key that we didn't do well, or a lot of people didn't do well the first round on the test, was we didn't change modes here. So you need to be clear that in the course of the test, you're going to have to make sure you're in the right mode when you do use your calculator, and that you may have to switch it from one problem to the next. Okay, so in the first one, what mode should your calculator be in? Good. So let's do that, and we'll see if we agree on what that is. And I'm not sure if I can use, I'm going to pause it here. I'm not sure if I can. So I can't share with you now, but are you getting for the first one that the x value, so we're going to get 4.3 times the cosine of 7 pi over 8. And in radian mode, I'm getting negative 3.973. I need nods of heads. Yes, you got the same thing, or no, you have no idea what I did there, Emma.
What did you get?
Yes. Claire, do you know how to do this?
Yeah.
What did you get?
So for the x value on part A, I got, I said 4.3 times the cosine of 7 pi over 8, and I got negative 3.973. We agreement? Jeremy? Okay. And then for the y value, I got 1.646. Then you got a switch mode. So the x value in the next one was 4.149. That sounds right. Now I didn't get to the last one. I can do it real quick. 6.2 sine of 312. And I'm getting negative 4.607. Excellent.